Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is Cambridge Physics 5054 course, and I'm your teacher, Mariam Rafique. Today we have to start a new chapter, that is chapter number 18, and the name of the chapter is Current Electricity. We know that electricity has many uses in our day-to-day life, and it is used for lighting rooms, working fans, and domestic appliances like using electric stoves, AC, and more. And all these provide comfort to people. In factories, large machines are worked with the help of electricity. So, before getting into the core concepts of this chapter, I would like to share some learning outcomes. Like state that a current is a flow of charge and that current is measured in amperes. Recall and use the equation charge is equal to current into times. Describe the use of an ammeter with different ranges and some assignment questions. So first we have to know that what is current. Current is the rate of flow of charge, Q, and when charges flow, they can be positive or negative. For historical reason, the direction of conventional current is taken as the direction a positive charge will flow. And here in the circuit diagram, you can easily see the direction of a conventional current, that is from positive to negative. Now, what is an electric current? For current to flow, you must have a complete circuit, as you have shown in the figure, and a power source is needed to create a potential difference. Now, what is potential difference? It is the difference of electrical potential between 2 points in a circuit. And when these conditions are met, free electrons move about inside the metal. Which way does current flow? Here you can see two simple circuits with different direction of current. The first one is from positive to negative, and the another one is from negative to positive. The unit of the current is the ampere, and it can be represented as capital A, and the symbol for the current is capital I. To measure the size of an electric current, an ammeter device can be used. You can see here in a circuit that along with cell there is a resistor and there is a ammeter device attached. Here you can see, students, some of the pictures of device called ammeter. An ammeter from ampere meter is a measuring instrument used to measure the current in a circuit. And electric currents are measured in amperes, hence the name. Instruments used to measure smaller currents in the milliampere or microampere ranges, and these are designated as milliamperes or milliammeter or microammeters. And you should know about this, that the ammeter is connected in series with the different components that you can see here in this diagram. Now, what does the ammeter actually measure when it is connected in a circuit? You might visualize the working of an ammeter as counting charges as they move through the instrument to see how many pass each second. So the amount of charge passing per second is a measure of the electric current. So lots of charged particles passing per second, a large current. Few charged particles passing per second, a small current. And we can refine this to electric current is equal to the amount of charge passing per second. This is equivalent to electric current, and that is equal to rate of flow of charge. More formally, perhaps current is equal to charge duration. And you can write this out in symbols. And that is the famous equation in current electricity. I is equal to Q into T, where I is current, Q is charge, T is time for which charge flows, that is called the duration. Now, what is electromotive force? We have to explain that the electromotive force, or you can say the EMF, is measured by the energy dissipated by a source in driving a unit charge around a complete circuit. So, electromotive force, you can say that in a cell or battery, the chemical changes take place which provide the energy required to push the electric charge, or you can say electrons, around the circuit. The EMF, or the electromotive force of any electrical source, is the work done by the source in driving a unit charge around a complete circuit. The SI unit for EMF is joule per coulomb, or you can say the volt. Now this is time for assignment, students. And here is a think, pair, share. There are 2 questions. You have to sort it out. If 30 coulomb electric charge flows past a point in a wire in 2 minutes, what is the current in the wire? You have to calculate the current here by using the equation we just have studied. The second question is, the current in a lamp is 0.2 amperes, and if the lamp is switched on for 2 hours, what is the total electric charge passing through the lamp? You can also use that equation to solve this question. Thank you so much and good luck.